Today's lesson will be focusing on the concept of limiting sum. A geometric series has a limiting sum or a sum to infinity if the common ratio r is a number between 1 and -1, meaning that the ratio has to be a proper fraction between -1 to 1. This means that the sum approaches a limit as the number of terms increases. So let's consider the following example. A frog starts jumping from a point that is 1 meter away from the wall. The frog's first jump was 50 centimeters, and each jump after that was half of the previous jump. The frog sees a princess that is 2 meters away from the wall in the same direction and wishes to reach her. Can the frog reach the princess? So let's put this into context. There's the wall. Okay, sorry about that. Whoops. Excuse my terrible drawing. But there's the wall, and there's the princess, and there's a frog that is starting 1 meter away from the wall. So that's the 1 meter. And the thing is, the princess is 2 meters away from the wall, so over here, and in the same direction, okay, so to the right of the wall. Now, the frog is going to jump 50 centimeters first, okay? So, if you think about it, this part is going to be 1 meter, so jumping 50 centimeters will be making them land somewhere here. And the thing is, each jump was half the previous jump, so the next jump is a ratio of half of 50, so that's 25. So this is 50, but half of that will be 25. So it's going to jump this much, okay? And then what do you know? The next jump is going to be half of this. So it would be this much, okay? Now, if they keep doing that, the question is, can the frog reach the princess? Well, no, because every single time that frog is jumping, they're jumping half the remaining distance left. So they'll never actually get to them, okay? So, ignore this for now, all right? We're just going to go straight to the formula, okay? All right? So, if we have a look at this, well, actually, no, you know what? Maybe it's important to actually go through this. Sorry about that. If you actually add up all the values here in meters, this will be 1 meter, 0.5, 0.25, and so forth, right? So each term after will be basically half of the previous term, okay? Now, if I keep adding these values here, you can see that these values get smaller and smaller and smaller, okay? Now, what happens is, if I add, just the first term, it's just 1. The first plus second term, it's 1 plus 0.5, which is 1.5. If I add the 3 terms, it will be 1.75, and so forth, okay? But notice how the values here, they're increasing, but slowly increasing, okay? It's trying to stop somewhere, and the number that it's going to stop at is, you can guess, it's going to be 2, okay? The limiting sum of this series is actually 2. Now, you can tell by, finding S6, S7, S8, but there's also a formula that we generate to do this. So remember S of n, the sum of n terms using a geometric series is this. We can actually see that r to the power of n, okay, is going to go to 0 if n goes to infinity, if r is a number between -1 to 1. And I'll give you an example of how that happens. So you know that this is the formula. Now let's just say r in this case is half, right? What's going to happen to this term then? Well, if r is half, and let's just say we have half to the power of, I don't know, like 100 or something like that. That means half times half times half, 100 times, which is going to be very small. We say that this is going to be approaching 0. So what I'm highlighting here, the r to the power of n, is going to approach 0, all right? We say that the limit of n to the power of infinity of that term, r to the power of n, is going to approach 0. So that means that that term there is going to approach 0, okay, when we have the limit of s of n, the sum formula, as n approaching infinity. And if we substitute it in 0 as that, then you only have a times 1 left, which is a over 1 minus r. Okay, and that's our formula here for limiting sum. The sum of infinite terms, given that the ratio is between -1 to 1, is a over 1 minus r. Okay, now moving on. I'm going to write that formula again and again and again. S of infinity is a over 1 minus r. Let's check first that this is a limiting sum. Your ratio in this case is 6 over 9, which is going to be 2/3. And you know that 2/3 is between -1 to 1. Okay, so it'd be a good idea to actually write this out first. Okay, sorry about that. We can say that 2/3 is between 1 to -1, so that means that has a limiting sum. Our limiting sum formula is a over 1 minus r, a being 9, and 1 minus 2/3 as the ratio. And if we put that in our calculators, or you know, if you just simplify the bottom, it will be 9 over 1/3, and that's the same thing as 9 times 3, which is 27. So this sum here is going to approach the number 27 as it goes on. Question 2. Find the sum to infinity of the geometric series with first term 0.2 and common ratio 0.8. So we're going to use that formula once again. S to infinity is equal to a over 1 minus r. Over here, we've already got a, and this is our ratio. So by substituting this in, we get 0.2 over 1 minus 0.8. And that is equal to, 1. Okay, because it's going to be 0.2 over 0.2. Okay, question 3. Find the limiting sum, okay, of the series. So in this case, let's see what the ratio is. All right, the ratio is going to be -1/4 over 1. And that's -1/4. Okay. Now, sum to infinity is a over 1 minus r, which is the value a here being 1, over 1 minus -1/4. Now that means, on the bottom, you get 1 plus 1/4, which is 5 over 4. And 1 over 5 and 4 is just the reciprocal of the fraction on the bottom, so it's 4 and 5. Okay? All right. So, moving on. Question 4. A geometric series with a common ratio 0.75 has a limiting sum, or sum to infinity, of 32. So in this case, this number here is S infinity, whereas this is just R. Okay, find the first term, which is A. So let's put our formula out, which is A over 1 minus R. Now, our sum to infinity is the number 32, so replace that by 32. A is something we don't know, the first term, and the ratio is 0.75. So, by replacing that in and simplifying our denominator, we get 32 equals A over 0.25, and multiplying that over gives us A being number 8. Question 5. An infinite geometric series has a limiting sum 30 and first term 12. Find the common ratio. So we've got S infinity, so sum of infinite terms. A is 12, and the ratio is R. The sum to infinite terms is A over 1 minus R. Replace the sum to infinity with the limiting sum 30, and that is equal to A, which is the number 12. Yeah? And that's over 1 minus R. So now we've got an equation to solve. Let's multiply 30 over 1 minus 30 times 1 minus R. That will be 30 minus 30R equals 12. Subtracting 30 over gives us negative 30R equals negative 18. And if I do that on the calculator, it should give me 0.6. Okay, so your ratio is 0.6. Okay? Question 6. The limiting sum of the series 1, negative 2p plus 4p squared, negative 8p squared, cubed, and so on, is 4/7. So there's our limiting sum, S of infinity. Find the value of p. Okay, so we've got A as 1. r is going to be negative 2p over 1, which is negative 2p. Okay? And then the sum to infinity, infinite terms, is a over 1 minus r. Okay? Now, what are we going to do here? We're going to substitute in sum of infinity as 4 and 7. That's equal to a, which is 1, over 1 minus r. Now, r is negative 2p, so we'll substitute in that. And again, we just solve. So 4 and 7 equals to 1 over 1 plus 2p. And now if we cross multiply, then 4 plus 8p equals 7. Okay? Subtracting 4 over 8p equals to 3. So dividing 8 over p would equal to 3 over 8. Okay? Question 7. Find the limiting sum if it exists for each series. Okay, so remember that our series only would exist if the ratio is between negative 1 to 1. Actually, this must be the case. So let's find our ratio. Our ratio in this case is 224 over 128. Now, using my calculator, 224 divided by 128 is equal to 1.75. This is clearly not between negative 1 to 1. Okay, so therefore, the limiting sum does not exist. Okay, since the ratio, since r is not between negative 1 to 1. Okay, so in an exam, if it's asking you something like this about why it doesn't exist, you must write it's not between negative 1 to 1. Okay, let's do the next one. The ratio in this case is going to be the second term divided by the first term, negative 180 over 225, and negative 180 divided by 225 is the number negative 0.8. So therefore, the limiting sum exists, okay, since it's between negative 1 to 1. And using our formula for limiting sum, a over 1 minus r, we get s of infinity equal to 225 over 1 minus the ratio, which is negative 0.8. Now, s of infinity would equal to 125. So as I sum all these numbers, it would come to a stop, okay, and that will be 125. It's getting closer and closer to that number. Question 8. For what values of m will the series have a limiting sum? Now, for this case, usually we start with this, but if we're finding the value of m, okay, which is basically part of the ratio, right? The ratio in this case is m over 2, right? If you think about it, if you put m as, let's say, the number 4, right? Would the limiting sum exist? Is this a number between negative 1 to 1? No. So you've got to put an m value here such that this whole term is going to be between negative 1 to 1. So we're going to say that the ratio is between negative 1 to 1. And we're just going to stick this in, the m over 2, into r's place. And so m over 2 will be between negative 1 to 1. And multiplying both sides by 2 will give us negative 2 to 2. This is our answer. For 9a, we do exactly the same thing for values of x with a series that have a limiting sum. So let's just find out the ratio. The ratio is minus 2x over 3 divided by 1, which is minus 2x over 3, right? And so this ratio, minus 2x over 3, we've got to set that between 1 and negative 1. We'll multiply both sides by 3 first, so that negative 2x is now between negative 3 to 3. But if I divide both sides by negative 2, you have to remember to swap the signs around. So this side will become 3 over 2, and this side will become negative 3 over 2. Okay? And you know that the arrows should point to the left, so we're going to swap these two terms around and also swap the arrows around. So there's our answer. Okay, so x is a number between negative 3 over 2 to 3 over 2, which is simply the same thing as negative 1.5 to 1.5. Okay, now that x is 1.2, according to the question, what's going to be our limiting sum? Well, if you find the limiting sum based on this only, s infinity is a over 1 minus r, which in this case is going to be 1 over 1 minus negative 2x over 3, which simply is 1 over 1 plus 2x over 3. If we replace x by the number that they said, which is 1.2, we'll have s infinity equal to 1 over 1 plus 2 times 1.2 over 3. And that will give us 5 over 9 once you type that in the calculator. And once again, this is your homework, but just please do that after your trial papers. Okay? All right. Here are some mixed series questions that we have to do. Okay? So these are just some notes that you should follow. All right? So in an AP or arithmetic series, the term minus the previous term is the common difference, whereas for a geometric series, you divide the term by its previous term and you get the ratio. So just know which one's which, okay? Which I'm pretty sure everyone is confident by now. So with exercise 5.2, you've got to determine whether the series is arithmetic, geometric, or neither. So let's have a look. Is this number going up by the same number? No. So it's not an arithmetic series. When you times 1 by 4, you get 4. But 4 would have to times by, well, I guess 9 over 4, okay, to get 9. And these two are not the same ratios, so they're not GP either. So the answer for this one is neither. Okay? Now for an AP, a good instance where you recognize it's not AP straight away is that it shouldn't alternate in terms of its sign. So it shouldn't go positive, negative, positive, negative. Okay? Because if you're adding values, you should make the number go higher. Or if you're decreasing the value by something, by minusing something, it should go lower. But in this case, it's just alternating. So it could be a geometric series or neither. Let's test. T2 over T1 will be negative 112 over 32. So by doing that, I get negative 3.5. Now if I test the same thing for term 3 over term 2, I get 392 over negative 112. So 392 divided by negative 112 would also be negative 3.5. And just check it one more time on your calculator for the next one. And I'm just checking that, and it is. So we can say, therefore, it's geometric, since the ratios are the same. Now, for the next one, what will this actually be? It goes 16, then minus 12, then minus 14, then minus 68. Okay. Let's see what the difference is if you get T2 minus T1. It's minus 12 minus 16, which is negative 28. So that's our common difference for the first two terms. Now if I do term 3 minus term 2, which is negative 40 divided, minus negative 12, and just be very careful with the negative, so it's a negative with negative, like that, which means negative 40 plus 12, and that's the same thing as negative 28. So it is, right? So the common difference is always the same, and if you check the next ones, it's always going to be the same. So therefore, this is an arithmetic progression, okay, since D is always the same. All right, question 2. This is an interesting question. What are the conditions for a series to be both arithmetic and geometric? So that means that your difference equals to your ratio. The only time when this happens is when you have the same number. So let's just say, for example, 2, 2, 2, so on. Okay? If I work out what the difference is, the difference is going to be 0. Okay, so this is always going to be the same. All right, the plus 0 to get to the next number. But it's also geometric because from one number to another number, you times by 1. Okay, so if a question is asking you a condition for both them being arithmetic and geometric, then you just have to list out the exact same number a couple of times. Okay, let's go on to question 3. For the series 18 plus 12 plus something, find the 16th term if the series is arithmetic. So this can be possible only if they give you 2 terms. If it's arithmetic, that means D is going to be term 2 minus term 1, which is minus 6. Okay, now A in this case is 18. It's always going to be 18, the first term. And if we find in the 16th term, well, we have to revise our formula for Tn in this case, which is A plus n minus 1d. T16 will be 18 plus 16 minus 1 times minus 6. Now, 18 plus 15 times minus 6 will give us negative 72. Okay? And that's how it is when it's an AP. Now, for GP, a geometric series, our ratio will be the second term, which is 12 over 18. 12 over 18 is going to be 2/3, right? A is still 18. Tn is going to be a r to the power of n minus 1. So in this case, the 16th term will be the first value, which is 18, times by the ratio, which is 2/3, to the power of 16 minus 1, which we know is going to be 15. So I'll do that straight away. Now let me just see if this actually pops up on the calculator. Okay, pops up as some strange number. Okay, but in order to do this really well, all you have to do is do 2 to the power of 15 first. Okay, that will give you 32768, and then 3 to the power of 15, which gives you 14348,907, and then just times 18 to the top. So 18 times 32768 gives you this number. Okay, doesn't matter if you actually don't simplify it, who cares? Okay, if you want to simplify it, I don't think your calculator can do it for you. I think it doesn't fit. Yeah, it doesn't fit. So you'd have to like divide by some common ratio or factor between them, but it doesn't matter. You leave it like that. Right. Question 4. The fourth term of a series is 1,512, and the seventh term is 5,103. Find the sum of the first 7 terms if the series is geometric. Okay. So we've got the fourth term here, T4, being 1512, seventh term being 5103. So if it's a geometric series, then we're going to use this formula. Okay, so T4 would equal to AR to the power of 4 minus 1, which is 3. And this is supposedly equal to 1512. T7, the seventh term, is going to be AR to the power of 6, and that is 5103. Okay, remember to always divide the equation that has the higher value of r, or higher power of r, sorry, okay, which is equation 2, divided by equation 1. So what this will generate is ar to the power 6 over ar cubed. So it's just that divided by that, and that's equal to 5103 over 1512. Now, simplifying the left side gives us r cubed by subtracting 6 by 3. On the right side, if I was to simplify that, I do get 3.375. Okay, and if I do the cube root of that, let me just double check that, it gives me 1.5. Okay, now after you do this, you got to find what is A. Okay? So sorry, you got to squash this in. Let's just sub it into 1. Okay? So if I substitute into 1, then A times 1.5 cubed is equal to 1512. And if I solve for A, 1512 divided by 1.5 cubed, A will be 448. So now that we got these two values, we can now find out what they want, which is the sum of the first 7 terms. So remember, Sn is A to the power of, or A times R to the power of n minus 1 over R minus 1. So S of 7 would equal to 448 times the ratio of 1.5 to the power of n, which we know as 7 minus 1 over ratio of 1.5 minus 1. So again, if I do that on the calculator, let me see what I get. I get 14413. There we go. All right, so try and squeeze that in. Okay. So that leaves me with a bit of space for arithmetic progression. So now I need to do the same thing for AP. Tn equals to A plus n minus 1d. So T4, the fourth term, is A plus 4 minus 1d, which you know is going to be 3d. And term 4 is going to be 1512. Whereas its seventh term, you know, is A plus 7 minus 1d, which is A plus 6d. That is 5103. Again, call that equation 1 and 2. But this time we're going to subtract 2 by 1. Okay? The effect of this is that we'll get the larger coefficient of d minus the slower one, whereas the a's will cancel. So we'll get 3d left on the left side. 5103 minus 1512 on the right side gives you 3591. And dividing by 3 gives us a common difference of 1197. Right? We can substitute this back into equation 1 so that A plus 3 times 1197 equals to 1512. So 3 times 1197 is 3591. Oops. And 1512 minus this answer gives us A being negative 2079. And we can now put this back into our formula here so that Tn equals to negative 2079. Oh, actually, no, do we have to do that? No, we don't, because we want to find out the sum of the first 7 terms. So we're going to use this formula. Sn being n over 2 and 2a plus n minus 1d. Okay? So S of n is equal to, well, we're not finding S of n actually, we're finding S7. That would equal to 7 over 2 times 2a. So 2 times negative 2079 plus n minus 1d, which is going to be 7 minus 1d, and that would be 6d anyway, so I'm just going to write 6. And d in this case is 1197, as we can see here. So let me just double check that to see if I've done it wrong. 2 times... Okay, I got it right. So the seventh sum of 7 terms in the series will be 10,584. Right, and that's it for this part of the work.